In this video, I'm going to use an Excel demonstration to underscore some key points about sampling distributions and about the effect of the central limit theorem on sampling distributions. So first, let me describe what this spreadsheet is. This spreadsheet has some data that it's working with, and that data is all the salaries for Major League Baseball players. I think it's from 2012. So there's 800 and some salaries. And then I have a plot here, a percent polygon, and there's a blue line for the population distribution and a red line for the distribution of the samples. So what I do is I randomly pull samples of this sample size from that population of Major League salaries. And when I pull samples, I pull 10,000 samples. So if the sample size is 1, I'm pulling 10,000 samples of sample size 1, taking the mean for each of the samples, of course it's going to be the value that's pulled, and then plotting that distribution of those means on the red line. Right now, you can only see one line, because if you take samples of size 1, the shape of the sampling distribution is going to be exactly the same as the shape of the underlying population. So this line here on the polygon is also what the salary distribution looks like for Major League Baseball salaries. You have a whole bunch of them here around 500,000 to 1 million. And then as you get higher and higher salaries, you have fewer and fewer players making that salary. All the way up to here, up to 33 million, which is A-Rod. The dotted line here is plotted right at the Major League Baseball mean salary of 3.4 million. Over here to the right is a normal probability plot. This is a plot of the sampling distribution. So remember, if this normal probability plot is a straight line, that means that the distribution is approximately normal. So when I take samples of 1, the normal probability plot is nowhere close to being straight. And you can see here on the polygons that with a sample size of 1, the sampling distribution is this red line. It's highly skewed. Okay. So if I change this number to 5, what I'm doing is the spreadsheet is randomly pulling 10,000 samples of 5 Major League Baseball player salaries each. For each of those 10,000 samples, it's calculating the sample mean, and then it's plotting the distribution of those 10,000 sample means in this red line here, and comparing it to the distribution of the underlying population, the blue line. So you can see here with 10,000 samples of size 5, the population distribution is very skewed, but already the sampling distribution is starting to look a little bit like a bell-shaped curve. And if we go over here to the normal probability plot, it's getting a little bit straighter. Now, what's the rule with the central limit theorem? The central limit theorem says that no matter what the distribution of the underlying population, if we're taking samples of size 30 or more, the sampling distribution will tend to be approximately normally distributed. So we're just going to test that. Let's change our sample size to 10 now. See what happens. Okay, now look at the sampling distribution. Again, this red line is a plot of the distribution of the 10,000 sample means that occur when I choose 10,000 samples of size 10 at random from the Major League Baseball player salaries. It's already starting to cluster around the population mean. Remember, the mean sample mean is always going to equal the population mean, and it's starting to look more and more normally distributed. You can see the normal probability plot is getting closer to being straight. Well, let's go and take 10,000 samples of size 20. Now look at our sampling distribution. The means of those samples are clustered around the population mean, and as our sample size gets larger, remember the standard deviation of the sampling distribution, which is also called the standard error, gets smaller and smaller. That's reflected by this polygon being sharper peaked and more narrow. And look at the normal probability plot. It's getting almost to be a straight line. Now let's go to sample size 30. This is the magic number, remember. So now we're taking 10,000 samples of size 30, taking the mean for each sample, plotting the distribution of those means in this red line, and doing a normal probability plot on those 10,000 means. Now that's pretty close to normal. And if you look at it, you can see it's clustered right around the population mean, and it looks almost like a normal distribution. And we can keep going. Let's take it to 50. 10,000 samples of size 50. Again, it looks pretty normal. And as the sample size increases, the sampling distribution gets narrower and narrower. That means its standard error or standard deviation is getting smaller and smaller. And the normal probability plot straighter and straighter. Now I'm going to go all the way up samples of size 100. So again, what this is doing is pulling 10,000 samples of 100 baseball players at random, and for each of those 10,000 samples, it's calculating the sample mean, and it's plotting the distribution of those means here. So let's do it. So not a whole lot of change between sample size 30 and sample size 100. Okay. So this demonstrates some key points about sampling distributions and the central limit theorem. What is a sampling distribution? It's the distribution of values of sample statistics, in this case sample means, that occurs when you take a very large number of samples, technically all the possible samples of a certain size, and calculate that sample mean or other sample statistic for each one. This is the sampling distribution. Remember, the mean of the sampling distribution is always equal to the population mean. That's the dotted bar here. So the average salary for all the MLB players, our sample mean is going to be that. The standard deviation of the sampling distribution, which is also called the standard error, is always going to be the population standard deviation divided by the square root of the sample size. So the larger the sample size, the smaller the standard deviation of the sampling distribution. And we saw that the distribution gets narrower and narrower as sample size increases. So I'll go back to sample size of 15 just so you can see how now it's broader, the sampling distribution. Okay, and the final point is about the central limit theorem. And the central limit theorem, its implication for sampling distributions is no matter what the distribution of the underlying of the population. So here we have this blue line representing the highly skewed population distribution of all those MLB salaries. That doesn't matter. As long as we take samples of at least 30, then the distribution of the sampling distribution is going to be approximately normally distributed.